Hey guys, Mr. Ward here again. Day 3 of logarithms. Today we're going to start solving some equations. More math in a vacuum, not any applications yet, but we're moving that direction. So again, we started with operations, we moved to graphing, we had to add a little bit of properties, how to manipulate things, and now we're going to do some solving equations. So again, a little mad minute. Log base 2 of 32 equals x. 2 to what power? X equals 5. Hopefully this is coming quick to you now. Log base x of 64 equals 3. What cubed equals 3 equals 64, pardon me, must be 4. And the last one, ln of 5, looks crazy, but if you think about that as being an e, x equals just e to the 5th. Don't care what number it is. 2.71828 to the 5th power. E to the 5th is great. All right, let's do another little warm-up, which is pushing these together to a single logarithm. So that 2 can become the exponent. 3 squared is 9, plus becomes multiplication. So log of 9x. You can use parentheses to show the whole thing is the argument. Again, 2 becomes the exponent, subtraction becomes division. So I see a big ln of x over x plus 3 squared. Hopefully you're getting pretty good at that. Properties we did, and again, is it something that you did last year in A2? All right, reviewing equations we did last unit. If you can get bases the same, and do what then? Set exponents equal. No matter how you slice it, guys, the goal is to get the x down from the exponent where we can solve. Okay? What we do at first is we get the bases the same, then we'll do something a little different in a minute. What's another name for 8? 2 to the 3rd to the 3x. What's another name for 1/16? 2 to the negative 4th. Raise a power to a power I multiply. Bases are the same. I can set equal. X is down where I can solve it. Negative 4/9 is my solution. But what do you do when you have equations that you can't get bases the same? I can't turn a 5 into 84. I can't turn an 84 into a 5. Well, here's a strategy right here. Isolate the base, get the base alone, and then take the log of both sides. So is the base 5 alone? It is. So I'm going to take the common log of both sides. Yes, we could have just as easily did the natural log, but I'm going to do common log. Are they equal? Sure they are. I did the same thing to both sides. Property says I can shoot this down front. So I now have 3x log of 5 equals log of 84. What has the logarithm allowed me to do? Bring the x down where I can solve for it. X equals. I could make this a totally calculator inactive question as long as I accept from you this answer right here. Mr. Ward, the answer is log of 84 divided by 3 log of 5. Absolutely. If I said use your calculator now, 0.918. All right, let's do the next one. Now I did a common log here, but I might want to think of doing the natural log here. ln of e to the x equals ln of 43. Again, took the log of both sides. ln of e to the x, bring it down front. ln of e is 1, gets me just x equals. And again, calculator inactive, natural log of 43. Calculator tells me 3.761. Let me double check that. I did that on my calculator, but I want to make sure I get it right. Let me see where my calculator is. You know what? There it is. I was going to say, trust me, but you shouldn't trust me. ln of 43, 3.761, right on. All right, let's do it again. We're solving equations, okay? Now we have to isolate the exponential. See that 4 in front? It's multiplied. If we had an add, we'd get rid of it. So we divide both sides by 4. e to the 2x equals 20. Now we take that natural log. As you get better at it, can you take some shortcuts? Sure. If I take the natural log of e to the 2x, I write ln of e to the 2x. I pull the 2x down front. ln was 1, just turns into 2x. And again, a calculator inactive. Now be careful here. It's ln of 20 all divided by 2, not ln of 10. ln of 20 divided by 2. And what I got for an answer is x equals 1.498. Isolating the exponential, solving for e. All right. Make them a little bit messier. We're going the other way. Instead of solving exponentials using logs, we're going to solve logs. How? Using exponentials. So first we're going to isolate the log. I can do that. Subtract 2, subtract 2. ln of x equals 3. Now what? Well, we have two choices. We can use that around the world. Not a big fan of that term. I like to rewrite it exponentially is what I call it. Or exponentiate. I believe we did this on day 1. Exponentiate. Tough spelling word. All right, so if I did blue, exponentiate, red, rewrite it exponentially. What's that? That's e to the power of 3 equals x. There's my answer. X equals e cubed. Or if I exponentiated each side, I would go e to the ln of x equals e to the third. Make them the exponents because they cancel. Either way you slice it, you get e to the third. I don't care what that decimal is, 2.7 to the third power. I'm going to guess, I don't know, maybe in the low 20s. Isolate the exponential. Divide by 2. ln of 5x equals 2. I'm going to rewrite it exponentially. You could have exponentiated, whatever you feel comfortable with. E to the second equals 5x. So x equals e squared over 5. I didn't do any of these decimals because that's a great answer. A little bit messier equation. To isolate, I got to do a little bit more, but it's easy. Algebra 1. 3 log of 2x equals 9. Log of 2x equals 3. Now, I'm going to exponentiate this one, okay? What's that base there? It's base 10. 10 to that, 10 to that. They cancel out, and I get 2x equals 10 to the third, also known as 1,000. So if 2x equals 1,000, x equals 500. If you didn't like that, from right here, I could have said, what's that base? It's base 10. 10 to the third power equals 2x. You still get to that 2x equals 1,000. X equals 500. All right, and now and only now do I have an equation where I have a log of both sides. When we have a single log on both sides, you can just set the arguments equal to each other. Nice and simple. That might be a strategy that you want to have in your toolbox, depending on the equations. All right, math in a vacuum. We did it. Equations. Now let's do something with them. If you invest $2,000 at 3%, what's the max amount? Max amount should tell me PERT. You will have after 3 years. Let's see. 2,000 e to the 0.03 times 3. And you should say that's an old review. That's easy. Okay? Plug that into my calculator. 2,188.35. Okay? But now I'm going to change it. Instead of saying how much will you have after 3 years, I'm going to say how long will it take to have $7,500? So now I'm going to still use PERT, but I know this. I know this. This is what I want. E, I don't know the time, but I do know the rate, 0.04t. And I have to solve that equation. That should look identical to what we just did. Isolate the exponential by dividing off the 5,000. 1.5 equals e to the 0.04t. These kind of get fun as you get good at them. I see that e, I'm going to take the ln. And again, you can skip a step, ln of this side, bring the exponent down front, get you that. And again, Mr. Ward, I have a calculator inactive answer. ln of 1.5 all divided by 0.04. That decimal I get is about 10.14 years. An equation we could not have solved without the use of logarithms. All right, so day 3 allowed us to use this new idea of a logarithm to solve some equations. First starting with exponentials, then we did some logarithm equations. Either way, it's another tool in our toolbox to be able to be a little more analytical in our work, and we even got to an application question or two. All right, well done today, folks. Next up, day 4. Have a good day.